Hello, my dear student. How are you? So, hope you are quite well. And in this present class, we are going to discuss a simple numerical. Though it is very simple, but it is very, very important for your exam purpose. Exam what? Exam for NEET, for JE, and for others exam. Only one numerical problem I am going to discuss, and I don't take your time too much. It will take some 5 to 6 minutes, and I'll discuss some important numerical problem on the chapter of solution. On what chapter? On solution. So let's start. So basically, so the problem is what what will be what will be the osmotic what will be the osmotic pressure what will be the osmotic pressure of a 0.1 mole 0.1 mole mono basic acid. So what will be the osmotic pressure of a 0.1 molar monobasic acid, and what is given if its pH its pH is 2.0 at what degree centigrade? At 25 degrees centigrade. So it is given. So what is given? The the concentration of the monobasic acid is given, the pH of the solution is given. So we are interested on what? So we are interested on two things. First of all, the degree of dissociation of the monobasic acid. First of all, the degree of dissociation of the monobasic acid, and secondly, the Van der factor. If we can derive the alpha means the degree of dissociation of the monobasic acid or any other electrolyte. Yes, you got it right. Any other weak electrolyte, and then Van der factor, then you can easily derive and we can easily answer it out. Okay, my dear student. So let's start. So it is a monobasic acid. So how many numbers of H plus ions will be there in a molecule of the monobasic acid? Yes, number one, only one. So as it is a monobasic acid, mono means one. So only one. So this is the Ha. So this is the Ha. Ha means the monobasic acid. So only one hydrogen is there, and when it dissociate, it will give H plus plus A minus. H plus plus A minus. So initially, what happened? Initially, initially concentration of the acid will be the C, and when initially at the initial time no H plus ion and A minus ion will be produced, so it will be 0 and it is be 0. So it is the concentration. So what will be the unit of the concentration? This is mole per liter, mole liter inverse. So what happened at equilibrium? at at equilibrium, so let's, it will form C alpha, and obviously it will also form C alpha. Why it is C alpha and alpha? What is alpha? Alpha is the degree of dissociation. Alpha is the degree of dissociation. Sorry. So what will be the alpha? Alpha is the degree of dissociation. So as from from C molecule, C moles, from C mole of Ha, from C mole of Ha, C alpha moles of H plus ion as well as C alpha moles of A minus ion is produced. So how many moles of the Ha, that is the reactant, is kept intact? So this will be the C minus C alpha, because it starts from C and it dissociates will to give H plus ion as C alpha mole and A minus also C alpha mole, because this is both H plus ion and A minus ion is produced in equal number. So it is also C alpha, it is also C alpha. So this is the equilibrium. So but the pH is given 2, pH is given to, as the pH is given to, that is minus log of H plus ion, that is concentration of H plus ion is 2. So concentration of H plus ion equals to 10 to the power minus 2. Concentration of H plus ion is the 10 to the power minus 2. Okay, so here is the concentration of H plus ion, that is, so C alpha is the concentration, nothing but the concentration of H plus ion is will be 10 to the power minus 2, and the value of C is given because the concentration of the monobasic acid, that is C, initially it is given 0.1, so C is 0.1. so what will be the alpha? Because in the beginning we said that we will be interested in the two things. One is the degree of dissociation of the monobasic acid and the Van Hoff factor. Now we are going to derive the degree of dissociation. So alpha equals to 10 to the power minus 2 by C. So the value of C is given 0.1. So what will be the alpha? Alpha is nothing but 10 to the power minus 1, that is 0.1. So it is the alpha. Now the total number of particles, total number of total number of particles after dissociation, total number of particles after dissociation, total number of particle after dissociation will be, so at after dissociation at equilibrium, mind it, we are interested in equilibrium. So total number of particle at equilibrium, so at equilibrium is C minus C alpha is there, Ha is there at equilibrium, H plus is also there, and A minus is also there. So these are the number of particles at equilibrium, number of particles in terms of moles, number of particles in terms of moles. So 1 C alpha cancel it out, so it remaining C plus C alpha, that is C taken it out, so C into 1 plus alpha, so it will given, so the value of C is 0.1 and 1 plus this is also 0.1. So this is the total number of particles. So actually I don't calculate it out here, so I just keep it as follows, that is C into 1 plus alpha. So just keep it as it is. So this is the total number of particle after dissociation. Now what is the number of particle before dissociation? So what is the number of particle before dissociation? So here total number of particle before dissociation, total number of particle before dissociation, it will just see, because at initially only Ha remains, so only C moles of Ha remains. So we are interested in the number of particles in terms of moles, so initially only C, and after dissociation it forms as it is. So the ratio of number of particles after dissociation and number of particles before dissociation, that is if it is 2 and if it is 1, so ratio of 1 and 2 is nothing but the Van Hoff factor. So what will be the Van Hoff factor? Van Hoff factor, what will be the Van Hoff factor? Van Hoff factor is 1 divided by 2. So 1 is C into 1 plus alpha and by C. So C cancel. So 1 plus alpha. So value of alpha calculated 1 plus 0.1. So it is 1.1. So Van Hoff factor is 1.1. This is I. So I is 1.1. Now it is very simple to calculate the osmotic pressure. So what will be the osmotic pressure? So the osmotic pressure, the formula of the osmotic pressure, I just written it out here. So osmotic pressure pi, the formula of osmotic pressure is I into CRT. Here the Van Hoff factor is taken into account. the Van 't Hoff factor is taken into account. Why does the Van 't Hoff factor is taken into account? Because the acid here, the monobasic acid here, is weak electrolyte. So as it is weak electrolyte, it gives partial dissociation. When partial dissociation or any dissociation, weak electrolyte or strong electrolyte, it doesn't matter. When dissociation or association of the electrolyte occurs, or very preciously, when dissociation or association of the solute occurs, then we have to take into account the Van 't Hoff factor. Otherwise we don't need to take it account. Okay, so pi equals to I into CRT. So the value of I, that is Van 't Hoff factor, is 1.1, and value of I is 1.1, and C is the concentration, is 0.1, and R is the universal gas constant. This is nothing but 0.082. And what is T? T is the temperature in Kelvin. So here T in degree centigrade is 25 degree centigrade. So in degree of Kelvin, this is 25 plus 273, that is 298 Kelvin. So just 298. So now what will be the unit of pi? So pi is nothing but pressure, osmotic pressure. Pi is nothing but the osmotic pressure. So the unit of pi will be in atmosphere. Okay, so as it is the unit of pressure, osmotic pressure, so the unit of pi will be the unit of pressure, and unit of pressure is here atmosphere pressure, because here the unit of pressure is atmosphere, because here we take universal gas constant in liter atmosphere. Now after calculation, the value of pi will be 2.69 atmosphere. So it is our answer. Pi is the 2.69 atmosphere. So my dear student, I hope you can learn little out of this class, though little, but it is important. And to learn something more, you must keep watching our channel, and you must subscribe our channel. And if you do have any queries, you can write it in the comment section. So my dear student, keep on learning, keep on learning. Unless or until you keep on learning, you cannot do any bright result. So be with us and keep our channel watching, and enjoy the learning, e-learning you. We are always with you, e-learning you.